In this lecture, we are going to explore the idea of handling exceptions at different levels. And to show you what I mean, we are going to set up a chain of function calls. Suppose we have a function 1 here, which is called f1. This function is going to print a message that it is starting execution. It is going to call another function called f2, and when it finishes execution, it is going to put out its ending message here. When we hit F2, we're going to put a starting message and an end message. And in the middle, we're going to call F3. F3 is going to print its own starting message and it is going to put out its ending message. This is the kind of setup we're going to put in place here. Now, if we call F1, for example, in our main function, we're going to hit the body of F1 and we're going to put out a message that we are starting F1. We are going to call F2 and F2 is going to start executing. So we are going to go from F1 and go in F2 and we're going to hit this line here. We are going to say that we are starting F2. The message is going to show up on our terminal. After that, we're going to call F3 and execution is going to go from F2 to F3 here. So what will happen, we will see that we are starting F3. It is what we see here. We are going to see that we are ending F3. That's what we see here. And after this, execution is going to go back where F3 was called. So we're going to come back after the call to F3 and we're going to say that we are ending F2 here. So this is the message we're going to see and that's what we see here. After this, we're going to go where F2 was called. So we're going to go to this line here and execute the line after the call to F2, and that's going to come here and say that we are ending F1. And then our program is going to end if calling F1 is the only thing we did in our program. This is the default behavior we get if no kind of exception is thrown in this chain of function calls. We are going to set up another function which is going to just throw an integer exception. So this is going to be our exception thrower. It is going to say that it is starting execution and it is going to say that it just ended execution. And in the middle, we're going to throw our exception here. So let's look at another kind of setup we can do here. So we have our chain of function calls here, but notice that in F3, we are throwing our exception in the middle of starting and ending F3 here. We are calling our exception thrower function. So this is going to change the flow of things dramatically. If we call F1 in main, again, we are going to start F1. We're going to see the message here. We are going to call F2. So we are going to start F2 here. We're going to see the message here. After that, we're going to call F3. So we're going to start F3 as we see here, and we're going to see the message here. And then we're going to call our exception thrower function. What this is going to do, this is going to throw our integer exception. And remember, the exception is not handled in this function here. So the exception is going to propagate to the englobing scope where our function was called here. So we are going to fall back in the scope for F3 and the C++ runtime is going to see if there is a catch block that can handle this exception at this level here. But we're not going to have any catch block that can handle this exception. So the exception is going to propagate to the englobing scope. And the englobing scope for F3 happens to be F2 because it is F2 that called F3. So we are going to fall back here looking for a possible catch block that can handle our exception here. In F2, we're not going to find any catch block that can handle an integer exception. So the exception is going to propagate back to the englobing scope. The englobing scope at this point is the code that called F2 here. So we are going to go in F1 because that's where we called F1 here. So we are going to go back in F1 because that's where we called F2 here. In F2, we're also not going to find a catch block that can handle this exception. So this is going to propagate to whoever called F1, and that's going to be our main function. And let's suppose that we don't have a catch handler to handle this integer exception. The exception is not going to be handled and our program is going to crash. That's what we see here. So we are going to start executing F1. We see the message. We are going to start executing F2. We see the message here. We are going to start executing F3. We see the message here. But when we start our function that throws our exception, the exception is not going to be handled anymore. So code execution is going to freeze. The C++ runtime is going to try and propagate the exception to englobing scopes until it finds a possible handler, but it's not going to find that, and our program is going to crash at this point here. That's why nothing else is going to happen in our program. The moment we hit our thrown exception, code execution is going to freeze at the point in this function call here. This is what I want you to see. But it is possible to handle these exceptions at different levels in our function calls here. We are going to set up a simple example and show you that we can handle the exception at the level of the function 3 as we see it here. And we are going to try and go through this and see the flow we get when our program runs as we see right here. So we are going to suppose that we are calling F1 in main again. And we are going to hit the body of F1. We are going to start F1. That's what we see here. We are going to start F2. That's what we see here. F2 is going to call F3. So we are going to start F3. That's what we see here. And we see a message output here. And then you see that in F3, we have a try catch block. So our problematic code is going to be wrapped in a try block. And we're going to put a catch block, which is going to handle a possibly thrown exception. Now, what is going to happen? The exception is going to be thrown. We know that we throw it, and it is going to be handled in this catch block. And this is going to solve the problem we had of the crash that was freezing execution at this line here. We are going to hit the end of F3. So that's what we see here. Notice that the exception thrower function doesn't end properly, but the damage is limited to this function because all other functions are going to end properly. So we're going to end F3 as we see right here, and the controller is going to go back to whoever called F3, and that happens to be F2. We are going to execute the line here saying that we are ending F2 here. That's what we have here. And the controller is going to go back to whoever called F2. That's here. We're going to execute ending F1. We're going to say the message here, and our program is going to end. Hopefully you can see that by handling this exception in F3, we have limited the damage to the exception thrower function here. And this is something we can achieve with our try and catch blocks. But this is not the only way to do things. It is also possible to handle our exception in F2. And this is the setup to do that. Suppose we are calling this F1 function in main again. So we are going to hit the body of F1 and start F1. That's what we see right here. F1 is going to call F2. We are going to hit the body of F2 and we are going to print this message here as we see in our output. F2 is going to call F3, but it is going to wrap the call in a try catch block. So in our try block, we're going to have the call to F3, and code execution is going to go in the body of F3. So we are going to see that we are starting F3 here, and our exception is going to be thrown. Code execution is going to freeze in the body of exception thrower, and the C++ runtime is going to look for a possible catch handler. It's not going to find that. It is going to propagate the exception to the englobing scope. That's going to be our F3 function here. And the C++ runtime is going to see if this function call is wrapped in a try and catch block to have a catch block that can handle the exception. It is not going to find any catch block at the level of F3 here. So code execution is going to still freeze at this level. And we are going to propagate our exception to whoever called F3 here. This is going to go back at this level. And we are going to see if we have a catch block that can handle our exception. We will be lucky to find a catch block here. It is going to handle our exception. And we are going to say that we are handling the exception in F2. That's what we see here. F2 is going to end execution. And we are going to see that we are ending F2 here. And we are going to pass control to whoever called F2. That's going to go at this level here. And we are going to see that we are ending F1. And our program is going to end properly. Hopefully you can see that the further away you handle the exception from the point where it was thrown, the damage is going to get bigger to your program. You are going to get more functions that don't end properly. For example, here F3 didn't end properly. You see that we are not ending F3. So whatever was after the thrown exception here is not going to run. For example, if we happen to be releasing some memory in this location, we're not going to do that, and we are going to leak memory in our C++ program. This is not good. This is not the only way to do things either, so it is also possible to handle our exception in F1. Suppose we are calling F1 in main. Again, we are going to start F1. We see the message here. F1 is going to call F2, but the call is going to be wrapped in a try-catch block. So control is going to go in the body of F2. We are going to say that we are starting F2 here. That's the message we see in our output. F2 is going to call F3. F3 is going to start execution. We see the call here, and this is our output message. And we are going to call our function that throws an exception. The exception is not going to be handled in this function, so the exception is going to propagate to the englobing scope. That happens to be F3 here. And we see that the exception is not handled at this level. We have no catch block. So the exception is going to propagate to the englobing scope. And that's going to be where F3 was called. We're going to come back in F2 here, and we're going to see that we don't have a catch block either. So the exception is going to propagate to the englobing scope. That happens to be whoever called F2. So we are going to come back to this level, and we are going to be lucky to find a catch block which is going to handle our exception. We are going to say that we are handling the exception in F1. That's what we have here. The program is going to end well in F1, so we are going to say that we are ending F1. That's what we see here. And our program is going to end properly. Okay, so now you see that the damage is getting bigger because now F3 didn't end properly, F2 didn't end properly. The only function that ended properly is F1 because that's where we are handling our exception here. But this is not the only way to do things either. We can go all the way and handle the exception in the main function. So you see that in our chain of function calls, we are really not handling the exception, but we can wrap our call to F1 in a try and catch block, and we can do something like this. So what this is going to do, F1 is going to call F2, F2 is going to call F3. You're going to see that all these functions are going to start, but the exception is not going to be handled in our exception thrower, and it is going to be propagated all the way to the main function. So F3 is not going to end properly, F2 is not going to end properly, F1 is not going to end properly. The exception is going to be propagated all the way to the level of F1 here. And that's why it's going to be handled. We're going to see that after all the function calls, we're going to come back in main and say that we are handling the exception in main, and we're going to see this end message. Now, this is really what I meant by saying that it is possible to handle exceptions at different levels in your chain of function calls. But there are a few things you should keep in mind. You can choose to handle your exception at whatever level you want in your chain of function calls, but in the extreme case, it is possible to handle all your exceptions in main by just wrapping all the code in a try block and handle all your exceptions in main. You can do something like this. But one thing you should notice is that the further you choose to handle your exception from where it was thrown, the more you risk for functions not to terminate properly. And this is really bad. If a function doesn't terminate properly, you run the risk of not properly releasing memory. You run the risk for the function not to do whatever it is you designed it to do in the first place. So it is really bad for a function not to terminate properly. So my advice is to try and handle your exceptions as soon as possible, and that's going to limit the damage to the function that happens to throw the exception, and all the other functions that called it are going to end properly, as we have seen in these slides here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is handling exceptions at different levels. We're going to grab our template files pretty quick and put them in place. And let's do this. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean up and put our things in place. The first thing we're going to do is set up declarations for our functions. So we are going to have F1, F2, F3 in place, and we are going to put in our exception thrower, which is going to start execution. It is going to throw our exception, and we are going to end execution of this function here. The first thing we want to look at is the regular flow of things if no exception of any kind is thrown. So we are going to go below the main function here and put in our code. We can do something like this. And we are going to set up our function. These are definitions. And what we have in front of the main function are declarations. Let's make this super clear. So declarations. And we have definitions below here. That's what we're going to be doing to try and make this a little bit organized. So now that we have the definitions here, but before we run this, let's look at the bodies of this function. You see that it is exactly the same thing we saw in the slides. F1 is going to print some messages and it is going to call F2. F2 is going to call F3. F3 is going to print some messages here, and we are going to get the flow we saw in the slides exactly. Now, what we are going to do is call F1 in main. Let's do that. And we're going to see what we get if we run this program here. Let's build and pass this through GCC, our favorite compiler. The build is going to go through without a problem, so we can clear. Or let's bring up a PowerShell window before we clear, so we can clear now and run Rooster. Now you see that it is everything we saw in the slides. Let's make sure we put our end message in place. We're going to say stdc out and say end, and say stdendl, and we are going to build again and make sure that we really see this. So the build is good as you see here. We're going to clear and run our Rooster application. We're going to see that we are going to start F1. As we see here, this is going to call F2, and the control is going to jump to F2. We're going to say that we are starting F2, and after that we're going to call F3. Control is going to jump to F3. We are going to say that we are starting F3, and after that we're going to end F3. That's what we see here. Control is going to go back to whoever called F3. That happens to be F2. So we are going to jump after the call to F3 and say that we are ending F2 here. That's what we see. Control is going to go back to whoever called F2, and we are going to jump after the call to F2 and say that we are ending F1 here. And the control is going to go to whoever called F1. That happens to be the main function. So we are going to come back to the main function, and we are going to execute whatever is after the function call, and we are going to say end here. This is what we see. This is the normal flow of things if no exception of some kind is thrown in our chain of function calls. This is the regular flow, and we are going to comment this out because we still have a few things I want you to see as we saw in the slides. So let's comment this out, and we are going to examine the case where the exception is thrown from F3 and not handled anywhere. This is commented out for now, but we can uncomment this because we want to try this out. And we are going to see that we have the same function calls, but in F3, we are calling exception thrower. And let's look at it again. We're going to see that it is going to start execution. It is going to throw our integer exception, and it is going to end execution. This is what we do in this function here. So we have seen the flow of things in the slides. If we do things like this, we're going to try and run the program and see that it is actually what we thought we would see in the slides. So let's clear and run Rooster. Now we are going to see that all our functions are going to start, but none of the functions is going to end properly. And the reason is we have hit exception thrower here. We have started execution as we see here, and we have thrown an exception which wasn't handled anywhere in our chain of function calls. So what the C++ runtime did, it saw this exception here and saw that it is not handled anywhere in this function. So it is going to propagate this back to whoever called this function here. Control is going to hit F3 because it is this function that called exception thrower. And we are going to try and look for a catch block to try and handle the exception. We're not going to find that. So we are going to propagate the exception to whoever called F3. That's going to come back to F2 here. But we see that F2 is not handling this exception either. Again, exception is going to be frozen at this point, and we're not going to find a catch handler. So we are going to propagate this to whoever called F3. That's going to be F1. We're not going to find a handler here either. We are going to propagate this to whoever called F2. We are going to propagate this to whoever called F1, and that's going to be our main function. We are going to hit this scope here. We're not going to find a handler, and our program is going to crash because this wasn't handled anywhere. That's why we get our termination here. This is what we see. Now you see that neither of the functions in our chain of function calls is ending properly. And this is really bad. We may leak memory. We may not get the behavior we intended to get. This is really bad. If exceptions are thrown, you should make sure you handle them in your C++ program. Now, we are going to comment out whatever we just did here, and we're going to put in a piece of code that handles the exception in F3. So let's comment this out. And we are going to go down and do that. Let's close out our output window here so that we can really see what is happening. We are going to throw the exception from F3, but we are going to handle that in F3 as well. That's what we are doing. We are going to uncomment this, and let's see what happens here. So our call to exception thrower is going to be wrapped in a try block, and we will have a catch block to handle this exception here. So what is going to happen is we are going to call all the functions like we did before. When we throw the exception, it is not going to be handled in this function here, so it is going to propagate to whoever called this function. At that point, we are going to hit F3 here, and we are going to be lucky to find that we have a handler here, and the exception is going to be handled at this point. Now, because we are handling this exception, F3 is going to end properly, so control is going to go back to whoever called F3. We are going to hit this line here, and we are going to execute the statement. After that, we are going to end F2 properly. Control is going to go back to whoever called F2. That's going to hit this line here. We are going to print it out. Control is going to go back to whoever called F1, and we are going to come back in the main function, and we are going to execute the line here. So except for our exception thrower, all the other functions are going to end properly, and this is the best scenario we can get if we have an exception thrown and not handled in our function here. Let's run and see that this is actually what we get. We are going to pass this through GCC. The build is going to be good. We can clear and run Rooster. We are going to see that all the functions are going to start. We're going to hit the exception thrower. You see that the exception thrower function is not going to end properly, but we are going to handle the exception in F3, and all the other functions are going to end properly, and we are going to end our program, and this is really good. But it is possible to also handle the exception either in F2, F1, or even in the main function, and we are going to look at these examples here. So let's comment out what we just did here, and we are going to make sure this is commented out properly, and we are going to go down and set up a scenario where we handle our exception in F2, and we're going to see what that does. Let's uncomment this. We are throwing from F3 and handling the exception in F2, and handling the exception in F2 really means wrapping the call to F3 in a try block and catching the exception, if any. That's going to start our function F1. That's going to start F2. And if we call F3, we are going to go in here. We are going to start F3. We are going to throw the exception, and it won't be handled either in this function here or F3. So all these are going to freeze. We are going to propagate it back to F2. So we are going to handle the exception in F2. F2 is going to end properly, F1 is going to end properly, and the main function is going to end properly, and we are going to hit the end line here. That's what we are going to see. Let's build and see that this is actually the case. The build is good. We can clear and run Rooster. So F1 is going to start, F2, F3, all are going to start. We are going to run our exception thrower function, but neither this function or F3 are going to handle the exception, so they are going to freeze. F2 is going to handle the exception, and it is going to end properly. F1 is going to end properly, and our main function is going to end properly. This is what we see here. But it is also possible to handle the exception in F1, and we are going to see an example of that. So let's comment out what we had here properly. And we are going to put in the code that handles the exception in F1. Let's uncomment this, remove our block comment here. And this is what we have. We are throwing still in F3, but the exception will be handled in F1 as you see here. So F1 is going to start. It is going to call F2 and F2 is going to start. F3 is going to start. That's what we are going to see. But the exception is going to be thrown in this function and not handled either in this function. It's not going to be handled in F3. It's not going to be handled in F2. The exception is going to be handled in F1, and we are going to see that F1 is going to end properly, and the main function is going to end properly as we see on the top here. We are going to print the end line here. Let's build and see that this is actually the case. We are going to clear because the build is good and run Rooster. F1, F2, F3 are going to start. We are going to throw the exception, and neither the exception thrower function or F3 or F2 are going to handle the exception. The exception is going to be handled in F1, and it is going to be the only function that ends properly in our chain of function calls. The main function is also going to end properly, and we are going to hit the end. This is what we see here. Hopefully you can see what we said in the slides, that the further away you handle the exception from the point where it was thrown, the more damage you get, in that more functions won't get to terminate properly. We can even handle the exception in the main function and make sure we have as more damage as we can. So to do that, we are going to comment out whatever we had in here, and let's make sure this is commented out properly again, and we are going to put in the code that is going to throw the exception and not handle it in any function call here. So F3 is going to throw, but neither F3, F2 or F1 are going to handle the exception, and we will need to handle that in the main function here. That's what we are going to do. Let's comment out what we just did here to call F1. And we are going to put in a try-catch block that is going to call F1. This is what we are doing. So we are going to handle this exception in the main function. So if we call F1, F1 is going to call F2, F2 is going to call F3, F3 is going to call our exception thrower. This is what we have down below. Let's make sure we are there. This is what we are doing here. And the exception is going to be thrown. One thing you can do in Visual Studio Code is right click on the function call, and you can go to definition. This is going to bring us to the function here. We see that we are going to throw our exception, and it's not going to be handled in this function. So it is going to propagate to the level of F3 at this level here. It's not going to be handled. It's going to propagate to F2. It's not going to be handled here. It's going to propagate to F1. F1 is not going to handle this either, so it is going to propagate the exception to the main function. And in the main function, we will be lucky to have a catch block, which is going to handle this. So in this case, neither F3, F2, or F1 are going to terminate properly. The only function that is going to terminate properly is the main function. And this is the most damage we can do in here. So let's make sure we run this to see the effect of this. The build is good. We can clear and run Rooster. You see that all the functions are going to start, but neither of these functions is going to end properly. The only function that is going to handle the exception and finish properly is the main function. So hopefully you can see that the further away you handle the exception, the more damage you do, in that you get more functions that don't terminate properly. My advice is to handle the exception as soon as possible in your function calls. For example, the best thing to do in here is to even handle the exception in the exception thrower function itself. And that's going to put the damage to the maximum, because even this function is going to end properly. So for example, what we can do is wrap this guy in a try catch block. We can do this. We're going to put a try block, and after that, we're going to put a catch block, and this is going to catch an integer exception, and we are going to put a message and say that something went wrong, for example, and we are going to put an end line, and with this, we can go in main and re-enable the call to F1. We can comment out what we had before, and we are going to uncomment F1, the call to F1 we should say. And what I am going to do is keep in the calls we are doing here, and we are going to see that all the functions are going to terminate properly. In this case, even exception thrower is going to finish properly because we are handling our exception in this function here. So the exception is not going to leave this scope. It is going to be handled and this function is going to terminate properly. Let's make sure that we make our throw statement show up in our try block. We can do something like this. And now if we run, we should see all the function calls starting and ending properly, even the main function here. And this is really cool. This is what you should do. You should make sure you handle the exception to the closest point possible from where it was thrown. That's going to limit the damage of functions that don't terminate properly as a result of unhandled exceptions. Let's build our program and make sure that we see this in action. The build is good, we can clear. And if we run Rooster, we're going to see that all the functions are going to start properly. Even exception thrower is going to start properly. It is going to say that's something wrong and it is going to end well. And all the other functions are going to end well. And this is the best case scenario. This is what you should aim for in your C++ program. Okay, this is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see that we can have multiple handlers for an exception. Go ahead and finish up here and meet me there.